Hi guys, today we are going to see about problem solving in AI, particularly the second topic of formulating the problems. In previous video we have seen about problem solving process. In today's class we will see about the formulating the problems. While I'm saying formulating the problem, no, identification of the problem is the first step in problem solving process. Many questions can be answered while defining a problem. Once we get the answer to these questions, no, we can say that the problem definition is complete. To mention a few, what characteristic the class of problem to be solved, what method or technical is used in the current stage, what information is necessary to specify a particular instance. During the course of getting the answers, the specification of the achievable objective is very important. Every problem has certain initial condition from which different actions are initialized. Finally, a set of actions or methods to be defined that cause the transition are also important here. A problem statement can be a description of the data, method, procedure and algorithm that are used to solve it. Once the problem is identified, we need to be very precise and specific with respect to the problem space along with the target that we need to achieve. At this stage, the assumptions or limitation of solution, if you have any, no, are specified so that the solution quality is measured against the defined problem objective and requirements. That is what we have identified as a problem statement. The next important step here is here we have the analysis and representation of the task knowledge. It means that usually we understand the problem in terms of diagram or description and so on. No? But in AI, the target is to use mission to solve a problem. Once the solution is planned and feed to it, this is done using a state space diagram. Okay, so the problem is defined in terms of state. Each state will be the abstraction of all available information. Solution to any problem in the state space, no, each of these states is actually using the application of the actions or the operations to the previous stage. For example, if I say that another operator is going to apply, so till the final state will be achieved, the process will go on with a sequence of actions. This approach will be called as a state space method. Okay, what we called this approach is a state space method. Here, it represents the steps to be involved in the formulating of the problem. Let's begin with a state space approach for problem solving using a very well known puzzle. Okay, we'll see with a puzzle also. According to the steps, we'll see with a puzzle approach. Here, the very first thing is a problem identification and problem definition. The second one will be a problem space. Then we'll have the task knowledge. At last, we'll go with your state space. We'll see the following problem formulating steps with your puzzle. Here, you consider this is your puzzle with your 3 cells in the 4 cell board. It is a 4 cell board. We have only a 3 cells on that. One is an empty. Okay, which is filled with a single digit, and the cell is a one is a left one. Okay, left blank. The game here is we have to change the position of the digit under the blank cell of the board to arrive to a new board position. Okay, here the rule of the game is the blank space you are having, no, that has to be changed with your position with a digit of the horizontal or your vertical movement. Okay, it represents the first diagram, no, this table shows here, this is your initial state. Okay, this is our initial state and this is our final state. Okay, this is our initial state and this one is your final state of a game. Okay, this is a puzzle. In that puzzle we have a 4 cell board. On the 4 cell board we have a 3 coins. Okay, one is left as a blank. Okay, this is our initial state. We have to make this initial state into a, we have to convert this initial state to our goal state. Okay, we'll see with your steps. See here, I have two solutions for this. This is the first one and this is a second one. Two solutions I make it here. The first one, no, to reach from the initial state to the final state, always we have to move with a minimum number of moves, right? Even some, if the students is doing some program, no, with the minimum number of steps, they can able to produce the output, then the program will be a good one. We will say that when the algorithm or the steps to be followed is a best one is a which have a time and space complexity will be a lesser one. Okay, then only we'll conclude that steps or procedure will be a best of practice. So here also we have, I told you we have two way, no, one here the it defines here state space, the operations and the action space also mentioned here. The action space, that means what are the operations on the blank space you can able to perform is a, you can move with your up direction, move up, or you can move down, or you can move a left direction or in the right move. Okay, so the four possible moves are up, down, left and right. These are the four possible moves you can able to do with a blank space, right? Then here we have a different board position contribution, that are the elements of the state space. Here you have, this is no, this is the S naught is your initial stage. Okay, this is what we had in the initial board. Then if I have the blank space here, I have two options. One, this two can go down, 2, this 2 you have, no, that can go down, otherwise 3 can go in the right direction. Okay, here what they have done here, no, in the next step, up, whatever the content you are in the up, no, that value is go down. That's why we mentioned here as a up movement. Okay, we have mentioned here, no, as you represent it is the upward direction, whatever the content in the up position is down to the here. The next, no, they have moved it from left to the right. The element which is present in the left is moved to the right, that's moved to the right, that is why we have mentioned here as a left movement. Okay, so this is a way we can go and reach our goal state. But if you are doing the steps like this, no, in order to go to our goal state, it will take more sequential number of steps to reach our goal state from the initial state. So I have moved to the second way. Here within these two steps we have S1, another one is the S2, no, within these two steps we can able to reach our goal state. This is our goal state. So within two steps, the third one is our goal state. That also is another way to do this problem. Here what we have done, no, instead of moving this 2 up, or whatever the content in the up is going down, no, instead of doing like that, what I have done here is I make this 3 to the right position. The content which is in the left direction, this 3 is moved to the right position. That's why here we mentioned as left. Then what I done is whatever the content in the up is going down in the down. Okay, so here I mentioned that as a u to represent the upward content, the whatever the content in the up, no, that is moved now. The next is whatever I have in the right direction, no, right side, that is moved to the left. Here we have in the right 2, no, the 2 is moved to the left. So now we reached our goal state. Within this is our goal state. Within these two steps we have reached the goal state. If you go, you can try this the first way also. If you go, no, nearly 4 to 5 steps you can able to reach goal state. But the difference between these two way is within a 2 steps I can able to reach my goal state from the initial state. Okay, that's why I'm going to choose the second way. In likewise, you can have different way of methods to reach our goal state from the initial state. Okay, you can move all these way. These all called as a state space. We'll see in detail in the upcoming videos, but you understand that for a single problem, in order to reach from the initial state to the goal state, we can have so many ways. Okay, so many ways can be. The minimum number of steps to reach the goal state will be considered as the best method. Okay, So this is a way how I can able to reach my initial state to the goal state. Hope so. This diagram is very clear. That are actually two ways to solve this problem. We have seen what is the first way to get up with your solution of the goal state. The second one approach also. Okay. Now we'll see with your algorithm. Here, this algorithm, first you learn the problem, how to solve it, then you move with your algorithm, then it will be better understanding for you. Here in the algorithm, the first I make what is my initial state and what is the existing state. The very first time while you are starting the game, the initial state and the existing state will be the same. You please remember this point. While you are starting the game, the initial state and the existing state will be the same. Okay, then on the next step onwards, the initial state will remain as it is. The current state will be considered as the existing state. Always, wherever you are moving to the next upcoming sequential steps, all the current state will be considered as the existing state. Okay, then after you make the state, we are checking with the condition whether this state is not equal to my final state or not. If not so, then only you are going to the loop. This is your entire loop. If this condition is not true, then only you are going inside the loop. Otherwise, what we'll do? We'll come out of the loop and end the process, because if you reach the goal state, then that is the end of the game. That's why while the state is not equal to the final state, you are going inside, otherwise you will come out of the loop. Okay, so the next step, what I'm doing, the state what I'm having as a state, that is considered as my existing state. This is an assignment operator. So the state what we are considering will be assigned as my existing state. The next, as I told in the previous game, previous steps, we have seen 4 these operations can be performed on the puzzle. One is up move, then down move, or left or right move. Okay, these are the 4 basic operations can be done in the previous puzzles, right? So for each steps to generate a new state, I can choose any one. I can choose any one of these 4 steps. Okay, the next one, if new state is common to as my existing state, if those are empty, then I can do the process. Here see, the existing state is equal to the existing state with your new state. Okay, then that existing state will be considered as the new state that is assigned to the state. Hope you understand this step. We are doing any of these 4 operations, we have to choose it to get a new state. The next point is, if new state and the existing is an empty set. Empty set means I'm not having any other new moves, okay. Then after this operation is done, then what I'm doing is, the existing state will be union with a new state, then that will be considered as the existing state. That state will be assigned as a new state we are having, that is assigned as my state. Then again I have to check whether that state is not equal to null state or not. Every time I will check this condition. If I reach my goal state, I will come out of the loop. Otherwise, again I will go inside and choose any one of these 4 operations and perform the new state operations. Okay, this is a way how to perform the 8 puzzle or 4 puzzle problem what we have seen now. You can choose any puzzles like the n puzzle problem. This is the algorithm. Okay. Then here it is well defined problem which is described with your initial state, goal state, then what are the list of states available, what are the operations or functions you can able to perform. Then this will tell you what is the sequence of steps to be leading to your goal state. Okay, finally we'll check with your path cost. It means that from initial state to the final state, what are the functions I am assigning to make as a cost of the path. Okay, in the next video we will see what is the problem types and the characteristic. Thank you for watching. Thank you.